climate actually has something directly to do with the sun, with our magnetic field, with volcanism, with our solar system. Ladies and gentlemen, welcome in Robert Felix, the author of Magnetic Reversals and Evolutionary Leaps, The True Origin of Species. He is also the author of Not by Fire, but by Ice. Discover what killed the dinosaurs and why it could soon kill us. Mr. Felix has one of the most compelling synthesis of explaining weather and climate in a way I've never heard before. And while on this show today, we have meteorologists and climatologists who are going to help us understand what weather has to do with. Robert Felix is here today, and he's going to help us understand the truth about climate and weather. Ladies and gentlemen, please welcome Robert Felix. Welcome to It's Rainmaking Time.
Thank you, Kim. I'm really happy to be on with you. And, you talk about what's going on here with the climate, and I just want to start it out by saying it's a cycle, it's a cycle, it's a cycle, and it has nothing to do with what humans may or may not be doing on this planet.
Let me ask you something about it's a cycle, it's a cycle, it's a cycle. In your book, Not by Fire, but by Ice, you speak about the correlation between extinctions and ice ages, and extinctions and pole flips, or magnetic flips, as you call it, every 11,500 years. Can you bring us into the verifiable, evidentiary body of knowledge that needs to be articulated to even have a frame of reference to be discussing the subject?
Well, there's a cycle called the Milankovitch cycle, and this cycle, I really don't know of any geologist in the world who would disagree with this cycle. And the cycle, it's not something I've invented. We've known about it since at least the 1970s. In the 1970s, there was a group called CLIMAT, Climate Long Range Investigation, Mapping, and Prediction. And it was spearheaded by people at Lamont Doherty Earth Observatory. It had more than 200 institutions involved. What they did is they drilled cores into the ocean floor where they could look at sediments that had been deposited as much as 500,000 years ago. And they discovered that ice ages have come and gone, according to a cycle, approximately every 23,000 years, with a smaller ice age at the halfway point every 11,500 years. So I look at this cycle every 11,500 years where the climate warms up to periods of warmth even warmer than today, and then we descend into an ice age almost instantaneously.
And talk about the instantaneously, because what blew my mind reading the book was that it doesn't have to get that much colder to move into an ice age. What do you mean?
It's already cold enough. Going back to Lamont Doherty Earth Observatory, the head of Lamont Doherty Earth Observatory back in the 1970s, a guy by the name of Morris Ewing, said, it's cold enough right now to have an ice age. All we need is more moisture. Boy, have we been getting it. It's I believe that precipitation has increased in the United States by more than 20% since Morris Ewing said those words. So to me, I see it happening right now. And when I say fast, when I went to school, way back when, we were thinking that it took thousands of years for an ice age to begin. But in the late 1980s, there was a group called GRIP, Greenland Ice Core Project, and they drilled cores, instead of into the ocean floor, they drilled cores into the ice in central Greenland. They went down more than 2 miles into the ice and then pulled up these cores that were about 4 inches in diameter, and they were able to look at those cores and see what happened as much as 250,000 years ago. They discovered that every ice age in the last 250,000 years, and I mean every single one without exception, began in less than 20 years, sometimes in less than 3 years. And they did it from periods of warmth as warm as today or even warmer than today. There was the Eemian period about 120,000 years ago. Actually, it lasted from about 125,000 years ago to 115,000 years ago. And the Eemian period was even warmer than today's interglacial. And when it ended with a bang, went into full-fledged glacial severity in less than 20 years. So that's what I mean by fast.
That's great. And also, I appreciate what you just said. Could you explain the fact that the glaciers are growing? Because what I've heard is that the glaciers are shrinking. What is the story, and how does one verify evidence of that?
Oh, that drives me nuts because I keep seeing pictures of melting glaciers, and, we're just not being told the truth. When I do radio interviews around the country, I ask the host if they are aware that glaciers are growing right here in the United States, and almost invariably, they've never even heard of that. But in California, on Mount Shasta has 7 glaciers. All 7 glaciers are growing on Mount Shasta and have been for 50 years. Some of them have doubled in size, but we're not being told about it. In Washington State, on Mount Rainier, there's a glacier there called the Nisqually Glacier. In the 1920s, I believe it was 1929, but anyway, the Tacoma City Light began measuring the Nisqually Glacier because they needed to know what water levels were going to be coming down the various rivers in order to generate their electricity. So the Nisqually Glacier is the most measured glacier in the northern hemisphere. The Nisqually Glacier is growing thicker at the rate of 18 feet per year. And yes, it had been receding, but since 1998, the Nisqually Glacier has been advancing. The Emmons Glacier on Mount Rainier is advancing. Crater Glacier on Mount St. Helens, when did Mount St. Helens erupt? I think 1980, May of 1980. There was a great big glacier on Mount St. Helens that totally melted, and the ice and slurry and mud and trees and everything came raging down the Toutle River, so that the glacier was destroyed. Well, that glacier on Mount St. Helens, it's now called Crater Glacier, has made a tremendous comeback. It's now bigger than it was in 1980. But are we hearing about it? No. Glaciers are growing. Glacier Peak in northern Washington, glaciers are growing. Mount Shuckson in northern Washington, glaciers are growing.
Why, for example, do I read that the Arctic shelf is receding and pictures of polar bears are seemingly being taken, falling into the water because the ice is melting? What is occurring that is manifesting pictures like this and information like this?
Part of the reason is those pictures of polar bears were taken in August when the ice melts every year. So that's part of it.
And I heard it's on the eastern side of the Arctic.
Well, what I look at, now I know that some of the Arctic ice has been melting. I agree with that. It's like in Antarctica, the ice in West Antarctica, which is a peninsula sticking out into the ocean, that's melting. But the ice in the rest of Antarctica is growing thicker. It's a little bit like saying no one seems to realize how big the Antarctic ice sheet really is.
How big is it?
Well, we look at the globe, and you just see this little tiny area of ice down at the bottom of the globe. The Antarctic ice sheet is twice as big as the continental United States.
Wow.
The area where the ice is melting is tiny in comparison to that. The comparison I make is if you were looking at the entire United States being covered with ice, and then half of the ice in Oregon were melting, that's essentially the percentage we're looking at. So the ice is melting in a half a state, and our headlines are telling us that the ice is melting all over.
It's out of context, then, is it?
It's not true. Now, in the Arctic, I agree that it appears that the ice seems to be melting, but even during the depths of the last ice age, the ice in the Arctic was not much thicker than it is right now. And that has had scientists confused for a lot of years. How could that happen that the rest of Canada was covered with 2 miles of ice and the Arctic was not covered any more than it is today? Well, the reason, I think, and we can get into this later, but I think it has to do with underwater volcanoes.
Yes, and in your book you talk about, it's called volcanism. I keep thinking of Star Trek when I hear that word. That underwater volcanism has a huge impact on our weather. I don't understand that. That's wild. Explain it.
Well, if you think about El Nino, is during an El Nino, the ocean warms up on the Asian side of the Pacific, that the Pacific warms up, and then that heat travels across the Pacific, and when it comes to the United States area or to South America, it creates these giant rainstorms, because as that area of the ocean warms, it sends ever more moisture into the sky. You mentioned clouds at the beginning of this. Well, that heating ocean is what sends all the moisture up there to create those clouds, and it comes to us as giant rainstorms.
But how does the volcanism impact weather?
Well, because the underwater volcanism heats the ocean. You know, I hear about humans heating the ocean, and yet the ocean, the heat begins at 2 miles down. I do have a paper on my website that shows that scientists have found that the heat begins at 2 miles down. Now, I don't know how we humans can be heating the ocean 2 miles down before the surface heats. Anybody who has a swimming pool, if they've tried to heat their swimming pool by blowing a fan over the top of it, they know it doesn't work. It has to come from the beneath.
So the ocean is primarily warmed from down 2 miles deep. And ocean warming, if I'm understanding your books and what you're saying, ocean warming also plays a role on weather.
Oh, it controls the weather. It controls, and I don't understand all of it, and I think when we have Joe D'Aleo on, that a meteorologist, we'll learn more about that. But yes, because it controls the jet stream, everything about our weather comes essentially from the ocean. As you said earlier, is run even before that from the sun.
Okay, ladies and gentlemen, please welcome Joe D'Aleo. He is the owner of icecaps.us. He's a meteorologist. He is a person who's articulate and committed to getting the truth out about weather and climate. He has a extremely popular site, icecaps.us, with millions of people going to it. Joe D'Aleo, welcome to It's Rainmaking Time.
Thank you, Kim. And I would like to follow up on what Bob has said. He did talk about the ice in the Arctic and Antarctic and volcanism. And the Arctic ice has indeed diminished in especially since 1999, and reached a record in the satellite era. During the period from 1979 on, we've been able to see the Arctic ice and measure its extent. And we had the least amount of Arctic ice in 2007, and they made a big deal about that. But you haven't heard that it has recovered quite a bit since then. This year, at the minimum, in September, we were 26% more in our extent of the Arctic ice than in 2007. So it has come back. Now, the Arctic ice is floating on water, unlike the Antarctic ice, which, for the most part, is on land. There is certainly some sea ice in the surrounding waters. But it is subject to melting from beneath. If the oceans in the Atlantic and Pacific are warm, and some of that warm water can make its way underneath the ice, and it does, the currents carry that warm water under the ice, it thins the ice, and you wind up with a smaller extent, thinner ice that melts during the summer, but comes back during the winter. This is not a new phenomenon, though. As Bob has said, there's cycles and cycles, and there are cycles in this Arctic temperature and Arctic ice that have been observed. The 1930s to 1950s, we had similar reduction in the ice in the Arctic. Also back in the 1800s, when the Siberian oceanographers and fishermen tell us that they caught codfish off of Siberia in the Arctic. So this is not an unusual phenomenon. It does not relate to CO2, but does relate to ocean heat. In the Antarctic, as Robert said, the ice has thickened, and in fact, the total extent of the ice, according to those same satellites, has reached a record maximum in 2007. Since 1979, and the melting last year was the smallest ever on record, and we continue about a million square kilometers above the the 31-year average in the Antarctic ice coverage. When it comes to volcanism, volcanoes affect the climate also by spewing ash, but more importantly, sulfur dioxide high into the atmosphere. And when it gets high up, 80 to 100,000 feet or more, it has a long lifetime, and it quickly gets converted to what we call sulfate aerosols that act like little mirrors to reflect the solar radiation that comes from the sun back to space. And the result is that less sun energy gets through to warm the surface. And we wind up with 3-4 years of cooling. And that's been clearly seen in the temperature records in the 80s after El Chicon and Mount St. Helens, and in the 90s after Pinatubo. In times of very low stratospheric or high-level sulfate aerosols, like we've had in the early part of this decade, the atmosphere is cleaner and more radiation gets through, and we wind up with a warming. So some of the changes that we've seen in the last 2 decades can be explained by volcanism in the atmosphere.
Why do you think, not to derail the scientific part of this, but why would something NOAA, and can someone explain who NOAA is?
They're the National Oceanographic and Atmospheric Administration. That's our government agency responsible for studying and reporting data on the oceans and the atmosphere.
Okay, thank you. You know, they say, NOAA has said that 80% of volcanoes are actually underwater. I didn't know that. I don't think the public would know that. So when you talk about volcanism, volcanoes being a key, one of the keys, impacting climate, I'm stupefied that it's off the table of human consumption and awareness as being a huge impactor of, warming the oceans, but also altering weather.
Kim, can I come in on that?
Please do.
Okay, because when NOAA said that 80% of volcanic activity occurs underwater, I first heard about that in the early 1990s when I began researching for the book. But, that was in 1991. In 1993, at that time in 1991, NOAA thought there were about 10,000 underwater volcanoes in the entire world. That was 1991. 1993, they discovered another 1,133 underwater volcanoes down off the coast of Easter Island. They were shocked. So they increased the world supply of underwater volcanoes by 10% in just a matter of months. They also discovered underwater volcanoes, rift volcanoes off the coast of Oregon, off the coast of Washington, that they weren't really aware of. Now that was 1993, so they thought there were 11,000 underwater volcanoes. Now, if you visit NASA's website, they estimate that there may be as many as 3 million underwater volcanoes. It is incredible how the knowledge has changed since 1991.
Well, do you think, I guess my question on this is, and I just want to stay on it till I have a clear sense of this for the public, if that's true, even if it's true by 20%, isn't that going to impact ocean warming critically?
It has to impact it. There's... And the fact of the matter is that volcanism has increased. My understanding is that above water volcanism has increased in the last 100 years, and that if underwater volcanism has increased, I would assume that, if above water volcanism has increased, I would assume that underwater volcanism has increased even more. So what we're looking at is that the above water volcanism is pouring ash and sulfur and everything else into the sky, which is cooling the skies, while at the same time the underwater volcanoes are heating the water and sending more moisture into the sky. So you have more moisture rising into skies that are cooler, which to me is a recipe for disaster.
Let me ask you this. If the glaciers are growing, I want to go back to the glaciers for just a minute. What are the tools or what are the instruments or who are the people that measure the glacier growth or recession? Who are they?
Well, first, let me just mention how many more glaciers are growing than we're being told about, because glaciers are growing in New Zealand. All 50 glaciers are growing in New Zealand. Glaciers are growing in Greenland, at least growing thicker. Glaciers are growing in Antarctica. Glaciers are growing in Iceland. They're growing in South America. There's the Pio 11 glacier. It's the largest glacier in Chile. It is growing. The Perito Moreno Glacier in Argentina. It's the largest glacier in Argentina. It's growing. Glaciers are growing on the tallest mountain in France, Mont Blanc. Glaciers are growing in Canada on Canada's highest peak, Mount Logan. But, they try to cover this up. The article I read about Mount Logan, it said that Mount Logan was growing taller. Satellite measurements show that Mount Logan is growing taller. You had to get about 5 paragraphs down into that article before you discover the reason it's growing taller is because there's more ice accumulating. So
I didn't know that ice had anything to do with mountain growth.
Well, it only in the respect of measuring it with satellite measurements.
Gotcha.
So it's the mountain itself is not growing, but the satellite measurements show that something's there, so it's ice.
Okay, can we bring in Dr. Tim Ball? Tim from Canada, who is a climatologist trained out of London, England, who is also a teacher and a writer for Canadian Free Press. Dr. Tim Ball, thank you. Amongst many other things.
Yeah, well, thank you, Kim. It's very interesting to listen to all of this because, of course, I've watched for 40 years the evolution of climate and climate science. And what's interesting is that meteorology is actually a subset of climate. It's the study of physics of the atmosphere. And just to clarify some things for the public, when they stand outside, they experience weather. And that weather is what scientists call a white noise. That is, it's the sum total of a whole bunch of individual noises that scientists call red noise. And each of those red noises, and you're discussing some of them here, the volcanoes and the ice, glacier, and so on. But that white noise that is the weather is everything from cosmic radiation in deep space to what you're also discussing, and that is the heat off the bottom of the oceans. Now, that's collectively called geothermal heat. When you discuss it as volcanoes, that leaves the impression in the public's mind that it's individual volcanoes. It is, but the public also need to know that there are what are called mid-Atlantic or mid-oceanic ridges, long ridges of where very thin crust of the earth and a lot of heat from inside the earth is being put into the oceans as well. If you're going to understand the weather, what you experience, and the analogy I'd like to use is not particularly good, but it's like standing outside of a football stadium with 500,000 fans all cheering, and the noise you hear is the collective noise, the white noise, that's the weather. But what we're trying to do is identify individual noises from within that stadium. And it is that complex, and that's why it's so difficult. Now, that's weather, and that's what you experience at any moment or during a day. But climate is the average of that weather over time or in a particular region. And one of the difficulties is that studying weather is difficult enough because you've got Joe as a meteorologist and so on. But the study of climate is a generalist discipline. In other words, you've got to bring together all of the expertise of everybody who's studying cosmic radiation to studying the sun and on and on and on, and bring that all together. And the analogy I like to use is that the climate is the full picture. But what we've got in today's world, because of specialization, is individuals who've got one piece of the puzzle.
Kind of like touching... Dr. Ball, kind of like touching an elephant and you touch one part of its body and you have your eyes closed and you say, I'm touching a tree. And your eyes are closed and you're touching one part of an elephant and you think you got the whole thing.
Okay, and of course they've made that even worse because, as you and I discussed, they've got the focus on CO2, which is one very, very, very small part of the total weather and climate system, and they've been able to focus attention on that, get the world's attention on that, and that's a question that people need to ask themselves. But back to my original point about weather and climate, Bob mentioned Milankovitch. Well, I recall at the beginning of my career, you go to conferences, and if anybody dared to suggest that the Milankovitch fit or was an explanation, they got attacked immediately.
What are you talking about? Hold on 1 second. We got to take you back because you're very much within your discipline and gestalt of understanding. And you can go 100 miles an hour. We want to stay very, very slow with the public who needs the grounding, and so I just want to bring you back and talk about what is it called,
Milankovitch.
The Milankovitch. Yeah, Say what it is.
Yeah. Well, he was a Yugoslavian, Serbian, actually, scientist who realized that the various Sun-Earth relationships were a critical factor in determining the weather and the climate that we have on Earth. Now, this is not a new idea. I mean, the first people to look at changing orbit of the Earth as it affects the climate was a Scottish scientist by the name of James Kroll. And 150 years ago, he was calculating how the changing orbit of the Earth, caused by the gravitational pull mostly by the gravitational pull of the planet Jupiter, would affect the amount of energy the Earth received over time, and therefore that would affect the weather and climate. And so Milankovitch, and then a little bit later on, about 130 years ago, they realized that the tilt of the Earth is constantly changing, and I'm not just talking about the wobble, the actual change of the tilt. We say it's 23.5, but as I like to joke, that's just close enough for government work. Well, what Milankovitch did was Milankovitch brought all of these things together, and he did his work in the 1950s, and incredible the amount of calculations that he did pre-computer, and it came up with how the amount of energy the Earth receives varies with the combination of the changing orbit, the changing tilt, and something called the precession of the equinox. And that gave an average of variation of the amount of energy that the Earth receives from the sun. And, of course, that was plotted, and Bob talked about Ewing. And Ewing and Don had a theory about Arctic ice, but there was another book that came out about 1970s called The Deep in the Past. And this was a sort of a trade book that was trying to link those deep sea sediments that Bob talked about with the glacial weather patterns. But as I said, Milankovitch still wasn't accepted at that time. I recall 1989, a conference where somebody presented Milankovitch and nobody questioned it. And so I knew that at about that time, the whole Milankovitch concept as just part of the cycles of the weather system was generally being accepted. And I think that one of the things that you're hearing from Bob and from Joe and so on is how recent not only the weather records are. I mean, we're talking about Arctic ice, and it's really only valid data from 1979 to the present time, and yet the Earth's 5 billion years old. And then also the fact that so many of these mechanisms and things, I mean, I watched the introduction of the El Nino. It started as the Walker circulation, and then it became the Southern Oscillation, and then it became El Nino, Southern Oscillation, and on and on and on. So I would like to say that with the climate puzzle, we haven't even got the four corner pieces, and that's how you do a puzzle. You find the corner pieces so that our understanding of the oceans, our understanding of the atmosphere, our understanding of the land surfaces, and the understanding of space.
We are in space.
Yeah,
I mean, this is another thing.
And then when you start talking about the edge pieces of the puzzle, they're simply not there. Now, just to finish up on the geothermal thing, I wrote a textbook published in 1987 was the first edition, and I had a reviewer. I put in there that, geothermal, that is the volcanic under the ocean, should be considered. And, a couple of the reviewers just rejected it. And I still put it in the book. But, these ideas of because all the textbooks assume that the only source of energy for the Earth's atmosphere and weather is the sun. And of course, when the textbooks start with that, and then you go to the computer models where they virtually ignore the sun, it's incredible what's going on.
So let me ask you this.
As I said, what we're really doing is we're seeing the evolution of a science, but being blocked by, and I know we don't want to get into this part of it yet, but being thwarted by political inputs.
I do want to delve into the IPCC, and I want to talk about a couple of the communication of inquiry or the community of inquiry and the terms of reference, which have to do with limiting the scope of discovery a little bit later. But I want to stay in two more things that I want to bring in.
Yeah, well, just one comment I wanted to make. We're talking about the glaciation, and Bob's bringing forward the fact of the glaciers advancing. One of the big mistakes that's made is that it's assumed that glaciers are only about temperature. And when I did my graduate level classes in climate, one of the first ones, especially the general one on climate change, the first lecture I would give was showing how a glaciation is caused by the Earth cooling. The second lecture I gave was and I proved that how glaciation caused by the Earth warming. And of course, what Bob is referring to and is how quickly you can go into glaciation. But glaciers are built by snow. Yes, the temperature has something to do with it. There's no doubt about that at certain points. But if you have more snowfall, and enough of it survives through the summer melt, then you are in a cycle of building of layers of snow, which then become glaciation. The mistake that's made is that glaciers are simply about temperature, and the same mistake is being made about tree rings. They assume
What's a
that
tree ring? Wait a minute.
All about temperature.
Hold on 1 second. What is a tree ring?
Tree rings, what it started out was that you cut it through a tree, and you've got these concentric rings. Each ring is supposedly represents 1 year of growth. Originally, it started out as dendrochronology. Dendro is Greek for tree. Chronology is time. And so you're using the tree rings to determine time. But it's starting at the University of Arizona with people like Fritz. And again, I watched all of this evolve. Dendroclimatology developed, where they realized that the width of each ring was an indicator of the weather patterns, but again, it was assumed primarily temperature, and from that you could then reconstruct temperatures of the past. So that became one of the indicators of past climate change. And it's unfortunate that it's been so badly abused in what's called the hockey stick, because one of the difficulties we have, Kim, is that we've basically got three periods of climate study. The one is what's called the secular or instrumental period, which everybody assumes gives us very detailed and accurate record, and that's simply not true either. And then you've got the historic, which is human records and observations and so on, and that generally covers about 3,000 years. And then you get into the biological and geological. One of the advantages to tree rings, of course, is that the trees are growing now, but they were also growing before we had instruments. And I worked with people like Peter Scott up at Churchill and Joe D'Aleo, and I had reproduced temperature records for Churchill going back 200 years. Well, they could then take those temperature records, compare with them with the tree rings that they had, and then presumably you could link back. And of course, this is part of the difficulty as well. I mean, we're talking about the mechanisms of climate, but what's really lacking as well is good, long, detailed records, data. And one of the things that's happened, and I watched it in my career and yelled about it but got nowhere, we've got less weather stations in the world now than we had in 1960.
While you're on that, I want to stand by. I want to bring in Joe D'Aleo. Are you there?
Yes.
Could you talk about in our initial conversation you were sharing with me, and I want to make sure I'm articulating this correctly, that there's an organization which took a look at the 1,200, is it 1,200 weather stations?
1,221, yes.
1,221 stations, that basically that they were not kept up to date, that they were not accurate, that they were the primary data for some of the underpinning of what is considered to be global warming. Let me make sure you articulate it correctly.
Well, those stations are in the United States only, although there's some indication that similar issues exist internationally. And it was discovered first by a professor at University of Colorado, Roger Pielke Sr., who did a study of the climate stations in eastern Colorado. And he was very surprised to find that the majority of them were not sited properly. They weren't located in as the National Weather Service's prescribed stations should be located, which is on a grassy surface 100 feet away from the nearest a building or trees, open to ventilation, that a lot of these were next to buildings or on concrete or on rooftops or next to air conditioner. So he published on that, and that got Anthony Watts, who was a meteorologist in California, interested in looking at that problem, and went to look at a few stations in California and discovered that indeed was the case. And he decided to start a volunteer network of meteorologists, climatologists, other scientists interested in the issue to go and investigate all 1,221 stations, take photographs from all directions, use satellite photography to look from the top, and document the siting of these stations. And they were surprised to find many were on concrete, on roads, in parking lots, on rooftops, next to air conditioners, in waste treatment plants. And in fact, of the 1,221 stations, they've currently surveyed about 1,000, and 90% of them they found to be poor or very poorly sited using the government's own criteria. And in all cases, the siting favors a warm bias, virtually all cases, of more than a degree Celsius or say 2 degrees Fahrenheit. So that is certainly a contaminant to that data. But that's only one. Tim mentioned the big dropout of stations globally that took place around 1990. In the 1960s and 70s, we had about 6,000 stations reporting. After 1990, it dropped to less than 2,000. In fact, in the last year, in most months, our data centers are using about 1,000 stations. So 80% of the world stations are not being used.
Why?
And well, some of them dropped out with the fall of the Soviet Union, probably because of inability to continue to support them financially. But it appears that in a lot of cases, it's our governments and our data centers not going after the data. In Canada, for example, we have very few stations in the global databases. We do have big holes also in Brazil. And most of Africa is missing, large holes in Australia and in the former Soviet Union. So we're at Greenland.
I have a question for the lay audience, which includes me. Why would we depend today on these stations, these separate stations? Why can't we just do everything by satellite and look into real weather or climate via satellite and get our information?
Well, we do, actually. We do have satellite microwave sensing of the atmosphere and lower atmosphere since 1979. And we believe it is more accurate than these stations globally, the station databases, that in addition to the stations that disappeared, and a lot of the other stations, it was a tenfold increase in the number of missing data inputs or months. So there were big holes in that data. But we do have good satellite data going back to 1979, but because it doesn't go all the way back to the 1880s, it is not used by our governments when they do their long-term analysis. It should be. It is a better data source than our station database.
So when we get the news about weather, where is it emanating from? What is tracking the weather in different parts of the world then?
Well, there are data centers that are responsible for assessing on a monthly basis the state of the global atmosphere in the U.S., also the U.S. NOAA, the National Climate Data Center in Asheville, does an assessment at the end of the month. There's another center in the U.K., the Hadley Center, that the IPCC uses in their analyses, that does their own assessment of the global temperatures. NASA does theirs using the NOAA data, and they do a little bit of an adjustment to that data and come up with their numbers. It's pretty close to NOAA, but we get it from those primary sources. But we also get the data from the two different locations that track the satellite data, one at the University of Alabama, one in California, that takes the satellite data and assesses the global temperatures from that.
Okay. So,
Kim, can I chime in here?
yes, and then I want to bring Robert back. Okay.
Okay, sorry. Just very quickly to follow up on what Joe said, one of the reasons that they closed down some of the surface stations, which are the ones that he was talking about that are problematic, was they thought the satellite would be able to provide all the data. And there were a lot of problems because, first of all, they found out that the satellites couldn't see through cloud. It couldn't tell them whether it was raining or snowing or even if there was precipitation. So the satellites were looked at as the panacea, and they basically closed the stations before they found out that the satellite didn't provide all the data they wanted. As Joe pointed out, the satellite gives you better coverage in terms of temperature, but it's actually taking the temperature down through the atmosphere. And again, I recall when the first satellite information came out, and it was showing sea surface temperatures much higher than we were actually getting from thermometers in the water. And then they discovered that they hadn't allowed for the fact that the satellite was actually measuring those particles of dust that we talked about earlier from the volcanoes, the aerosols in the atmosphere, and then you have to adjust for that. So, again, all of it's in its infancy. Joe mentioned the different agencies like the Hadley Center and so on. Well, they each come out with their own estimate of the average temperature for the Earth each year, and quite often they vary considerably. And you say, well, how can that be if they're all using the same weather stations? Well, they're not using the same weather stations, and not only that, but they're adjusting them separately. And I remember one year where the difference between the British estimate and the American estimate was a half a degree Celsius. Well, the listeners would say, well, that doesn't sound like very much. But then if you remember that they've told us that the global temperature is increased by 0.6 degrees Celsius over 130 years, and that was a terrible thing, it gives you an idea of the inaccuracy of the whole data system.
I totally get that. Several years ago, I did some television work for It's Rainmaking Time in Los Angeles, and I had the pleasure of interviewing Dr. Carol Rosen, who was the speechwriter and communication strategist for Wernher von Braun. And she had talked to me extensively about the fact that satellites can see 20 stories down below the ground at the level of a pin, that there is nothing that satellites can't see, and there's nobody that satellites can't find. She made it very clear to me to understand the level at which satellites can see, particularly at a military intelligence level. So what they say with regard to tracking weather, if that's true, maybe the fact that snow can't be seen, it would be hard for me to believe. The fact that rain can't be seen, maybe. The fact that there are some things it can't pick up. It's hard-pressed when you think at a military intelligence level what can be seen and what is being done. I don't know if I can accept it, not that I'm necessarily challenging what you're saying about what they're saying, but I don't know.
But Kim, what you have to understand is that the satellites are set up to detect the things that they want to detect. And so, for example, if you want to detect infrared, then you put up an infrared detecting satellite. And so, yeah, we've heard those stories about being able to read a license plate from space and all of the rest of it. And we see with Google Earth some level of that sophistication. But as I said, when you're starting to sense from a satellite all of the things related to the weather, it depends upon how you set the satellite up, what frequencies you're looking at, what level of ability to detect. So there's a whole lot of factors that determine it.
So it's another instrument, I guess. So it's how the instrument is, what the instrument is told to look for, correct?
Yeah.
Okay. Bob Felix, welcome back to It's Rainmaking Time. I wanted to ask you if you could explain to us what does the magnetic field have to do with the sun's activity as it relates to climate here and weather?
Well, what I see with the magnetic field is that earlier we were talking about the Milankovitch cycle and how ice ages come and go every 23,000 years with a smaller beat every 11,500 years. And then we go into precession of the equinoxes, which Dr. Ball mentioned, and all of these things tie together with, in my view, with magnetic reversals, because a lot of textbooks will tell you that the last magnetic reversal occurred about 780,000 years ago at the Brunhess-Matayuma magnetic reversal. But there are a lot more, and it depends on how you define them, but there's something called a magnetic excursion, where the magnetic North Pole moves south. For those who don't even know what a magnetic reversal is, maybe I should start there.
Thank you. I was just going to ask you. Please go right ahead. What is a magnetic reversal?
Well, that's a time in the past when compasses, instead of pointing toward the Arctic, would have pointed toward the Antarctic. And scientists now realize that the Earth's magnetic field has been reversed probably half of history. And the way they find this out, and I'm going to simplify, but volcanoes, lava, when it pours out of the ground, is non-magnetic. But as it cools down through what's called the Curie temperature, it takes on the magnetic field of the day. So what scientists can do, and again I'm simplifying, but they can drill a hole into ancient lava, they can drop a compass down there, and see which way was north at the time. So that in that way, lava it's absolutely recorded in the rocks as to which way the compasses would have pointed at any time in history. So, but what we've discovered is that magnetic excursions, where the North Pole moved south for a while and then moved back, those seem to occur about every 11,500 years in sync with the Ice Age cycle. There was the Gothenburg magnetic reversal or excursion, however you want to put it, from 11,500 years ago. That's when the mammoths went extinct. It was a big extinction.
In your book, you talked about how they're still finding millions and millions of bones frozen and millions of animals frozen still in time.
Yes, there's...
Explain that. That was so profound in your books.
Well, this is from 11,500 years ago and from 23,000 years ago. But some people, we always want to blame humans, and we still have people who are blaming humans for having killed off the mammoths. And yet there are estimates that there may still be the remains of 1 million mammoths still encased in the ice. We're still, as the ice melts in parts of Siberia, we still are finding mammoths, some of them still standing up, some of them with food still in their tummies. There was the Russian Academy of Scientists dissected one of the mammoths they found, and this was like 50, 60 years ago, but they dissected one of those mammoths, and the meat was still dark red and fresh-looking, as if it had been frozen just yesterday. They fed the meat to their dogs, and their dogs loved it. When they dissected the mammoth, they found fresh food in its tummy. Now, what that means is that where that mammoth was living, it was warm enough that trees were growing, that plants were growing, that food was growing, and then suddenly something happened to bury that mammoth in snow. I call it 9 stories of snow, but something trapped that mammoth so quickly that it got fast frozen with that food still in its mouth. I think that comes from giant snowstorms that trapped those mammoths. And that's why I worry so much now about the fact that we're having more and more moisture go into the sky. We're having more and more giant snowstorms. We've already had, here we are in toward the end of 2009 in October, but we have already had record snowstorms in the United States and in Europe and in South America. I fear that we're headed into an ice age right now.
I want to talk about the sun with you. I want to go what appears to be that which is so far away from the concept of an ice age for a few minutes. It is estimated that the sun is 93 million miles away. Am I correct?
Yes.
That's the distance from the Earth to the sun. And yet, activity from within the center of the sun impacts, A, our magnetic field, and our climate and weather. Can you explain it?
Well, I'll just let me back up just a little bit because Dr. Ball had mentioned precession of the equinoxes.
We don't know what that is for those of us listening.
That has to do with the sun. So let me see if I can draw a picture of it. If you could, because our Earth revolves, we all know that, every 24 hours, and the Earth is tilted, as Dr. Ball mentioned, it's tilted 23.5 degrees. Well, if you could shove a stick all the way through the Earth right at our axis of rotation, that stick would point right now toward the star Polaris, toward the North Star. But it doesn't always point that way because our axis of rotation slowly rotates. It's kind of like a top. If you've ever spun a top, you've noticed that the top never stands straight up and down. It's always at a tilt, and its axis of rotation is always rotating. The same thing happens with the Earth. Right now, that axis of rotation points toward the star Polaris. 11,500 years from now, however, that axis of rotation will point toward the star Vega. 11,500 years from then, it will be back toward the star Polaris again. And ice ages seem to occur in sync with that rotation. It's called precession of the equinoxes. Now, there are going to be people who say, no, the precession of the equinoxes takes 25,580 years, or whatever it is. But I'm talking about this happening in relation to the solar system, because the solar system also slowly rotates. So when you put those two things together, the precession of the equinoxes part takes 23,000 years. I don't know why, but as this happens, as we do this rotation, our magnetic field strength declines, and then at a point where it gets to be about 15% of its normal strength, it suddenly turns and reverses. Well, our magnetic field strength has been declining. Our magnetic field strength has declined 2/3 in the last 2,000 years, since the time of Christ. And the rate of decline is picking up. So it concerns me that we are on the cusp of a new magnetic reversal.
And I interviewed Dr. Dean Bonley, who is a magnetism expert in Canada, who developed a bed called Magnetico. And what he shared was that the Earth loses 5% of its magnetic field now every 100 years. And that actually the loss of the magnetic field is actually partially responsible for a lot of the ills and the diseases that people are experiencing, and they don't even know why. It's just a part of the puzzle. I'm not saying it is the whole puzzle or blaming the magnetic field change, but that it has an effect on health and it has an effect on wellness. But
I've heard that. I don't know. I haven't researched that at all, so I have no idea how true or not true that might be.
Yeah. You said that in your book that our magnetic field is not understood very well.
Oh, no, it's not. I mean, right now, scientists are in total disagreement. Some think the next magnetic reversal could occur 10,000 years from now, and yet others say soon. I do in not by fire but by ice. I do quote others that say it could happen within the next 200 years. There's other scientists who say that a magnetic reversal would take thousands of years to occur. And yet there are scientists at the University of California who think it could occur in as little as 30 days. And they base it on volcanic activity again. I mentioned how they can determine whether there's been a reversal by drilling cores into the lava. Well, at Steens Mountain, Central Oregon, these scientists from the University of California, I think one of them was Michael Prevost, I'm not sure now, but they drilled cores into the center of the lava field at Steens Mountain in Oregon, and then they drilled cores into the edges of the lava field. And they discovered that their compasses pointed in different directions, which means that the reversal occurred during the difference in time for the center of the lava flow to cool as opposed to the edge of the lava flow, meaning that it may have occurred in as few as 30 days. So it's a very open science still.
Can I chime in a bit, Kim, with this, Timbal? Sure. One of the where we started to discover about the magnetic reversals was in the development of another whole theory that was very controversial, and that was the continental drift. The idea that the Earth's surface is made up of plates and they're moving around as the underlying mantle material moves around. And the magnetic striping that Bob is describing was one of the things that showed that these plates separated, and as they separated, the lava came up and cooled. And as they went across the Atlantic Ocean, you found parallel magnetic stripes, which really was like a tape recorder of the reversals. Now, again, this was great controversy, and Vine and Matthews at Cambridge that came out with this in 72. A lot of objections to it. In fact, there are still people that don't accept the idea of continental drift. But the problem is, again, the mechanism. I mean, what induces the Earth's magnetic field? And
doesn't the sun, in some level, have a direct relationship to the Earth's magnetic field?
The sun has its own magnetic field, and as each body does in space. But the Earth, you've got the magnetic lines at the present time coming out at the South Pole and going back in at the North Pole, and we call that normal. And then, of course, we talk about reversal as the opposite. But originally it was thought that the magnetic field was created by simply the Earth rotating. But the debate, and I recall of this going to conferences on this, the debate was, well, if there's reversal, and that's the mechanism, then the Earth has to stop rotating in one direction and start rotating in the opposite direction. And of course, there's no evidence to support that. The latest theory is that the Earth is actually three separate spheres. There's the solid inner core, the liquid outer core, and then the mantle.
There are some that even think that the Earth is hollow.
Well, no, I know they do. They talk about the hollow Earth, but no, it varies from very solid to relatively liquid. But each of these spheres is rotating at a different speed. And the theory is now that each of those spheres creates its own magnetic field that complement themselves to create, say, the pattern of magnetic field that we have now. But then, because they're rotating at different speeds, they cancel each other out, and then they come back with a different reversal, a polarity reversal. But that's the theory. And Bob is absolutely right. The debate about how long these reversals take to occur is very difficult because in the geologic record, it's estimated it's about 1,000 years from the beginning of the decline to the 0 point of what's called the Gaussian strength, that's the strength of the magnetic field, to then it rebuilds with a new reversal. And as Bob intimated, we know that there are very extensive extinctions associated with those reversals because, of course, without the magnetic field, you're not being protected from a lot of the harmful radiation from the sun and from space. So, again, this is all part of the complexity of understanding our Earth and our world. And so for people to come out and say, oh, the science is settled or we know what's going on, it just absolutely boggles the mind if you've done any study of this at all.
How would an astrophysicist speak to what we're all speaking to in terms of being a different discipline? How would an astrophysicist differ from a climatologist, which differs from a meteorologist, and Bob, who's put together the synthesis of a lot of evidence in all the areas.
I've worked with people like Willie Soon and Sally Baliunas and other astrophysicists, and of course, what they're looking at is how the sun functions, and in the same way that geoscientists are looking at the way the Earth functions. And I mean, for example, how many people know that the sun is tilted by 7 degrees? We talked about the tilt of the Earth at 23.5. The sun is tilted by 7 degrees. We've talked about Milankovitch, which is changes in the sun-Earth, the physical relations between the sun and Earth.
Apparently we're in a solar cycle, they say. They say we're in solar cycle 24 and that there's solar flares that they're watching.
Yeah, the solar cycles, the first one starts with Galileo in 1610, but they're not numbered until 1735, I believe it is. And so starting with that as number 1, we're now in cycle 23 and supposed to be going into 24.
And that's the one some people are concerned about.
There are a whole bunch of cycles. I just want to make one quick comment to Bob's comment about cycles on cycles on cycles. There was a conference in Warsaw in 1990. Scientists were arguing that everything's cyclical. It's just that there's such a complexity of cycles to separate out any one. And the Russians have also done a lot of work on the cycles of weather affecting economies. For example, the Kondratiev cycle. But the Western world was arguing, no, they were into chaos theory, that no, none of this is cyclical, none of it's predictable, and it's just chaos. You can't assume, because you've got a correlation, you can't just say because, there's more sunspots and the temperature's higher, you can't assume that they're cause and effect. Okay, that the sunspots, therefore, are causing the temperature to change. All you can do is say, look, there's a high correlation, but that isn't necessarily cause and effect. And it's one of the ones I spent hours talking to my students about this, giving them examples. And the classic one that's kicking around now is, there's a very high correlation between obesity and Diet Coke, because the biggest drinkers of Diet Coke are obese people. But you just simply can't make the cause and effect relationship like that. And that was the problem with the sunspot data. And but now, starting in 1991, there was a guy by the name of Christensen and Svensmark. They came out with this cosmic cloud thing that Joe was talking about. And we've known for a long time that there's more clouds than there are particles in the atmosphere to create the clouds. And then this idea that it was cosmic rays reaching the lower atmosphere. And so this was a mechanism. Now, the IPCC rejected it because they said, it's not proven, it didn't come out in time. And in the latest report, they just got a few lines directed at it, and that's it. But if you think about it, the cloud is acting like a screen in the greenhouse. And everybody's sort of getting an understanding of what the greenhouse is about. Well, the cloud cover acts like that screen, so it blocks the sunlight and cools the Earth, or if it isn't there, the sun gets in and warms the Earth. So we do have a legitimate mechanism now.
Why is the focus on carbon? And then we'll bring in the other guests as well. But what is this preoccupation with carbon? Where did it come from? When I read in your book that carbon is heavier than air, it completely blew my mind. So how is this possible that we're focused on taxing people for carbon when it's organic and it's heavier than air and it's everywhere? I don't get it.
Yes, I remember giving a talk in Coeur d'Alene a couple of years ago, and this old chemist stood up on the stage and asked anybody there if they remembered their periodic table, and reminded them that CO2 is heavier than air. So how in the world can it be rising up into the sky and creating these problems that you're talking about? In fact, this last summer I was visiting Chicago, and I went to visit the Museum of Science and Industry. And in the Museum of Science and Industry, they have a reproduction of a coal mine because there's so much coal that has been discovered under Illinois. And so we took this elevator ride supposedly down into the coal mine, and then when we got out of the elevator, there was somebody there to give us a safety lecture. And one of the things they had was one of those old-fashioned canary cages that the coal mines would have, because the canaries have such small lungs, and if there was something wrong with their oxygen supply, the canary would be the one to die and warn them to get out of there. Well, they look out for carbon monoxide, but one of the big things that those canaries could also warn them was of carbon dioxide, which sinks. So it's just amazing that we're worried about that. I think it all has to do with global governance. I don't think it has anything to do with the climate. And this is my personal opinion, but I think that this has to do with taking control of our lives. I think that the cap and trade thing that they're talking about could be more appropriately be called control and tax. So to me, it has to do with control and power. Nothing to do with the climate other than that they can sneak it by us.
The whole world, almost the whole world, all of the environmental, quote, activists, advocates. I've been an environmental advocate, okay, for years, and I was sure we were doing it. I mean, really. Now, I want to say this to all of you. Nobody can fault the people that are upset and want better for the earth, or the people that are connected to the planet and want to, quote, get rid of this enemy called carbon. But the thing is that it's an enemy that's been created or miscommunicated, because carbon is not our enemy, and the percentage of it that we have anything to do with is like what, 1% to 2%?
Oh, it's not near that high. I think in our atmosphere, if you took all of the CO2, if you could compare our atmosphere, let's say, to a basketball arena that holds 10,000 people, the carbon dioxide would amount to 4 seats in that arena.
That's shocking.
It is. It's just.
So how is it that the IPCC was formed? And
Kim, can I jump in on this?
Sure.
First of all, we've got to clarify for the listeners that carbon and CO2 are two different things. Carbon is a solid. CO2 is a gas. Okay. And this is one of the games that they've played, is getting this confusion, all right? And we talk about carbon footprints and so on. Bob is correctly talking about CO2. All right, and CO2 is presented as a greenhouse gas, and it's less than 4% of the total greenhouse gases, which most people don't know. And he's correct that it's more dense than air, but they assume that it's mixed evenly throughout the atmosphere and so on and so forth. And I mentioned earlier in one of my comments about, the analogy I use is it's like somebody's going to do a physiological study of Kim, and they take one wart on your left arm and
which you won't find. Go ahead.
And so
use a better example, for God's sake. Go ahead.
Yeah, well, this is representative of your whole body, and that's what they're doing with the CO2. Now, the question I keep asking people, and you're implying, is why has that become the focus? And I happen to think that it goes back to Morris Strong's statement 30 years ago. Morris Strong was an advisor to the Secretary General of UN, Kofi Annan. He came out of Canada and made a lot of money as an industrialist, and then decided that the problem, and this is his quote from 30 years ago, the problem for the planet are the industrialized nations, and isn't it our responsibility to get rid of them? And I want the listeners to think about, how would you go about doing that? Well, if you consider that the industrialized nations are fossil fuel driven, and to shut down those engines, or that engine of those nations, then you've got to shut off the energy flow. But if you do that, people will scream immediately. But if you can show that the byproduct of those industrialized nations is destroying the planet through climate change and global warming and so on, then you can effectively convince people to stop using the fossil fuels, which effectively gets rid of the industrialized nations. So Morris Strong, and he was challenged by Elaine Dewar, and you can read about it in her book on the Cloak of Green, And it's a wonderful book because she set out to write a book praising the environmentalist leaders in Canada. And in her research, she found out that these were not people that, they had a political agenda, and it was very egotistical and all the rest of it. But anyway, Maurice Strong, when she said to him, well, why didn't you go into politics to change things if you think that was the problem? He said, you can't do anything as a politician. I'm going to the UN, where I can get all the funding I want and where I'm not accountable to anybody. And he set up the United Nations Environment Program, out of which came the Intergovernmental Panel on Climate Change. Now, one of my experiences, I've chaired commissions and been on commissions of inquiry. The way that the politicians control commissions of inquiry is in the terms of reference. And if you go and look at the terms of reference for the IPCC, the first thing they give is the definition of climate change. And it effectively limits them to only looking at climate changes due to human causes. And if you look at any of their reports, they say, well, what are the major forcings? That is, what are the things that cause climate to change? All the forcings they list are human in origin. They don't even talk about natural forcings of climate. And we've talked a lot here about the sun. Well, that they don't even include the Milankovitch effect. It's not in their computer models. And yet we know it's one of the major mechanisms of long-term and actually year-to-year climate change. So Maurice Strong narrowed it down to the CO2 for that reason, and that's why it's become the focus for the whole world. And, of course, the politicians bought into it, Al Gore in particular. That's the reason that one little brown wart on the climate body has become the focus of attention.
How could other scientists throughout the world, I understand on your site, Bob, at Ice Age Now, that you said 31,000 scientists do not accept global warming or CO2 warming or as the cause of warming. How can any scientist then get on board something that is already by definition skewed in its definition? The terms of reference are tying the hands of real discovery. How is it that scientists can wake up every day?
Well, I can give you just a little microcosm of an answer there. In Washington State, the state climatologist, to begin with, the politicians said that the snowpack in the Cascades has been going down because of anthropogenic global warming. The state climatologist for the state of Washington disagreed with it. The politicians fired him. In Oregon, the state climatologist said, no, humans are not causing this. It's a natural cycle. The politicians fired him. In the state of Delaware, the state climatologist, he's a climatologist. That's what he's paid for. He said, no, it's not humans. They fired him. In Virginia, now Patrick Michaels, climatologist who's written books on climatology, he said, no, the humans are not causing this. The politicians fired them. Well, when you are a scientist and you see your boss get fired, what are you going to do? You're going to shut up. And I think, these people are being bullied, more than bullied. Their very livelihood is threatened. So I can understand how scientists who disagree won't speak up. And even the ones who do speak up, then they're marginalized, or they're fired, or they're called crazy, or they're called on the fringe. Dr. William Gray in Colorado is the top hurricane chaser in the world. He's been doing this for 40 years, and he calls it a total scam, and so they're marginalizing him. To me, that's how it's happening. I think it's an absolute shame.
I think that just to support what Joe is saying, and I've gone through this myself, and you only got to Google my name and you'll see the personal attacks on me. But I think that to put this in a wider context is important. Science works by creating theories or hypotheses. And then what happens is, and those are based on assumptions, then what happens is other scientists who are skeptics, because all scientists are skeptics, challenge that theory and they test it. And if the theory holds up, then at some point it becomes a law, such as Newton's theory of gravity became Newton's law of gravity and so on. And but what happened in this case was that they came out with this, and we've already heard the term anthropogenic global warming theory, AGW, that they came out with this theory and they said, CO2 is a greenhouse gas, it traps heat. If it increases, the temperature of the Earth will go up, and the amount of CO2 will increase because humans are putting more in the atmosphere. That became a fact almost immediately. And Richard Lindzen, many years ago, the Alfred Sloan Professor of Meteorology at MIT, he made the comment years ago in Discovery magazine that the consensus was reached before the research had even begun. Well, then when some of us came along and started to question and try to do the research, we were immediately marginalized, as has just been identified. And but there's other factors involved with it. And I understand. I mean, I spoke in Winnipeg in Canada here a while ago, and three government scientists came up after and said, "We agree with you, but we're afraid to say anything." Now, you could say, well, where's your courage? It's a free society. But I understand. People have mortgages. They have, children and so on. But there's another interesting part to this, Kim, and that is an awful lot of scientists have said to me, look, I don't agree with the global warming thing, but the minute I say it, I'm branded as a conservative, a right-wing nut. And I'm a socialist, or I'm a left-wing, or I'm a Democrat, and I don't want to be classified politically that way. So again, they keep their mouths shut. But as the comment was just made, the term bullying applies. They've effectively blocked the scientific method. But of course, the other thing that they're confronted with is that science has continued in spite of that, very slowly, and of course, all of the evidence coming forward shows that the theory is simply not correct, and that's why they're scrambling now to push data out and try and convince the politicians before they abandon it and abandon the Kyoto Accord, which is due to die shortly. So that's the history of it, and that's why CO2 became the focus.
There's an international treaty, as we all know, that is about to be signed in Copenhagen in December of this year, that, if signed, will change the face of life on Earth for all of us by creating taxes and footprints and regulation and monitoring and being penalized if you take up too much CO2 or use too much carbon. And my question is the following. I read the book, The Inconvenient Truth. How could a book like that with supposed computer modeling, and I saw the movie, how could something that elaborate be so wrong? How could that be constructed as being science?
Well, of course, it wasn't science. The one thing you've got to give to Gore's movie, Inconvenient Truth, is it's a superb piece of propaganda. It deserved the Oscar because it's from the land of make-believe. But it didn't deserve the Nobel Prize because the week before Gore got the Nobel Prize for that movie, a UK court ruled that there were 9 major errors and that the movie was politically biased. And obviously the Nobel Committee may not have seen the outcome of that court report, but all of the information in that the court used to reach those rulings was out there on the web. So clearly the Nobel Committee didn't do their homework and made a political decision. And of course they've done that now with Obama getting the Nobel Prize. But
what about the computer modeling though? Stay with the computer modeling.
Yeah.
There is some phenomenon.
The computer modeling is at the heart of all of this because the computer models, of course, have become the bane both of economics and of climate science and a lot of other science. I mean, the most stunning statement so far in the 21st century was when the former chairman of the Federal Reserve, Greenspan, and he appeared before the Waxman committee, Henry Waxman's committee, and he said, well, my model was wrong. And it was just a statement like that, no apology, no nothing. My economic model was wrong. He said, well, how long have you been using this model? 40 years. Well, I watched the introduction of models and modelers taking over all the climate conferences and dominating everybody because, we know better. Our models show this, that, and the other. The models simply don't work. You cannot model the complexity that is the Earth's weather system. And I have no problem with them using the models in the laboratory in this university is fine. But the minute you go public with the outcome of your models and say, no, this is accurate, this is predictable, and that becomes the basis of policy, then a whole different set of responsibilities kick in, and those simply haven't been addressed.
Well, is that also because whatever's put in the model, like model in, model out, it's as good as whatever you put into the model? Isn't that the nature of a model? Like, it's only going to be as good as the factors?
I don't want to dominate the conversation, so Joe, you can respond to that.
Yeah, absolutely. Garbage in, garbage out is what they say. And as Tim mentioned, the solar factor is minimized in the models. In fact, in the last run, in the most recent IPCC report, they downgraded the solar factor by a factor of 7 based on a single paper with an untested model that showed that the sun was not as important as they originally thought. And they certainly continued on with their CO2. They also built into the model a lot of what we call positive feedbacks. And that's really the key to producing the extreme warming in 100 years that some of the models produce, of 10 or 14 degrees. It isn't the CO2 that produces the warming, but the assumptions that they make that with a little bit of warming, you get a little bit more water vapor. With a little bit more water vapor, you get more convection or thunderstorms in the tropics, more high-level cloudiness, which traps more of the heat, and the Earth's heat builds up more and more. And it's been found with the satellites and with the weather balloons that warming in the tropics is not there. That the feedback is not positive, but a negative feedback, which makes the CO2 warming minimal. And that's why the models are failing. That's why the temperatures have gone down for 8 years when the model said it was going to go up, even as CO2 has continued to rise.
Yeah, and I think another thing, to go back to my point about theories or hypotheses and assumptions. I mean, for example, Einstein's theory of relativity is still a theory. The reason is because one of the basic assumptions is nothing can go faster than the speed of light. But there are physicists who are doing experiments showing that there are likely things going faster than the speed of light. If that turns out to be true, then E equals mc squared, which is the end product, but is only valid if the assumptions are valid, then it becomes invalid. Well, what's happening with the computer models, they're built on that same theory that if CO2 in the atmosphere rises, the temperature will go up. But here's the difficulty. In every single record that we have of any time period for any duration, the temperature rises before the CO2. In other words, the levels of CO2 are being driven by the temperature, not the other way around. So the most fundamental assumption in that computer model is wrong, which partly explains why every single forecast that they've made with those computer models, and they try to avoid the issue by saying, well, we don't do forecasts or predictions, they're scenarios, but regardless, the public take them as predictions, but every single one has been wrong, and yet they continue to use them to claim that this is the future.
That's exactly right. This is Bob. You know, Kim, you had mentioned the film Inconvenient Truth.
Yes.
And in that film, it has a graph showing CO2 levels rising, and then below that it has another graph showing temperatures rising. And it looks as if one is, that the rising CO2 levels are driving the temperature. I think that was the first part of that movie where I realized how propaganda-driven it was, what a lie it was. Yeah. Because if you put those graphs one on top of the other, which would be a more logical way to look at it, you put those graphs one on top of the other, you find that CO2 levels rise after the warming. In other words, in the past, for the last millions of years, just as Tim said, CO2 levels are a result of warming, not the cause.
Yeah,
so
by the way,
exactly backwards.
Yeah, Bob, one of the things, when the ice core record, which is the one that's used most, that shows the temperature and CO2 going up in consequence or in step, when that first came out, the Jouzel, the French scientist that produced that and did the ice core work, said, look, don't rush to judgment on this. But of course, what happened was, it looked so good that immediately they rushed to judgment. Now, if you go and look at that graph, you've got 400,000 years of record squeezed onto a page, so it's less than 4 inches long. And then what you don't know, most people don't know, is that they've smoothed the raw data with a 70-year moving average, so that so much of the variability is taken out of it. And as I said, the original producer of that graph said don't rush to judgment, but because it suited the theory that CO2 is the problem and humans are causing it, they rushed at it. And by the way, Kim, it's interesting now that everybody agrees that in that ice core record, the temperature changes before the CO2. But again, those few scientists that are pushing this, and they're particularly associated with the IPCC and the Climatic Research Unit at the University of East Anglia, they're not out there saying these things. They're not out there saying, well, look, Gore's movie has got all these errors, and yet they must know. And so it's the same thing as when James Hansen appeared before Gore's Senate committee in 1988 and said that, I'm 99% certain that humans are the cause of the warming. No scientist would say 99%. And he told Stephen Schneider after the meeting that maybe he shouldn't have said that, but he didn't go back and tell Gore that. He didn't go back and correct the record. And so this is the difficulty that you've got to, we talked earlier about the scientists being silent, but the ones that are the real problem are the 42 or 43 that Professor Wegman identified in his report of his investigation of the hockey stick, who all published together and clearly are all peer-reviewing each other's work. And one of the things that I noticed several years ago, I couldn't figure out why are they making such a big issue out of peer review? Because there's an awful lot of rubbish published that's been peer-reviewed. Well, now I know why. It was because they knew that they were peer-reviewing each other's stuff and that nobody could check them on it because editors will not release the name of who the peer reviewers are. But Wegman, in his report, and it's the most astounding report that I've ever seen a scientist write, basically said this is what they're doing.
So, in a sense, facts are that there is no global warming, that whatever's occurring with climate, we can't do anything about, and that the Earth is cooling.
No, Kim, can I just correct that a minute? You see, this was the argument. Up until 1998, the Earth was warming, but it warmed. The shortest term warming started in about 1980 up to 1998. Prior to that, it cooled down. From 40 to 85 or so, it cooled down. And then before that, from 1900 to 1940, it warmed up. And I like to tell people, I've lived through 4 climate cycles, and I hope to live through a couple more. But so when you say, well, the Earth is not warming, it depends on what stretch of the record that you choose to pick. Now, you could do it and say, well, as Bob was talking about, well, we're 22,000 years out of the peak of the last ice age, so really it's been warming for the last approximately 18,000 years. But there have been significant periods of cooling in that, the little ice ages that Bob talked about. So you have to be very careful. What you can say is, and this is the more correct thing, is that any temperature change, whether it's cooler or warming, has nothing to do with human activity. That's the critical point here. And so when they come along and as they did with me, and said, "Oh, you're a global warming skeptic," and say, "Yeah, well, all scientists should be skeptics." And I was as skeptical about the predictions of global cooling in the 70s as I am about the global warming in the 90s.
Right, but I totally get that. I totally get that.
Yeah, okay, right. Then they say, "Oh, well, you're a climate change denier." Well, they switched from global warming to climate change because the evidence didn't agree with them. That here you had cooling from 2000 to the present, but CO2 levels continued to increase in contradiction of their theory, so they shifted the goalpost to climate change. And then they said, "Oh, you're a climate change denier," with all of the Holocaust connotations of that. And I was first named that in the Times of London about 6 years ago. And I keep pointing out to people, I'm anything but a climate change denier. My whole career has been trying to teach people how much climate changes. And I think that that's one of the critical things for the public to understand. They've been educated to a view of the world that change is gradual over long periods of time. And as Bob is showing so well in his book and his work, and as Joe has shown very well in his work and on his IceCap webpage, you've only got to look at a very brief period of any part of the Earth's history and see that change and dramatic change is the normal. But what they've been able to do is convince people that sudden or significant changes, or the changes we're seeing now, are unnatural, which means, therefore, they must be something humans are doing, and when in fact they're natural. So that means they can never be wrong, because tomorrow there's going to be more natural changes, but they'll present them again as unnatural. And that's the rabbit hole that we're stuck into.
That's very well put. Bob?
Well, I look at right now that we're wanting to cut. We're being told we're going to be forced, if the law is passed, to cut our energy usage by 80%. And, I don't think people quite understand that that's not the same as just putting in a few of those Quirly-Q light bulbs. If we cut our energy usage by 80% in the United States, that means you're going to get to use your dishwasher once a week. You're going to get to use your hairdryer, probably not at all, because that would be superfluous. You're going to get to drive to work one day a week. It's all going to be rationed. And if our president signs the Copenhagen Treaty in December, we're going to have to be applying to someone in Brussels for permission to cut down a tree in our backyard. We're going to have to apply to somebody in Copenhagen for permission to repave our driveway. The farmer will have to apply to somebody for permission in Holland to buy a new cow. It is horrible what this will do to the standard of living of everyone in the world if this happens.
If in fact weather does get colder, and if in fact we do end up in a little ice age in different parts of the world, aren't we going to need our energy? Aren't we going to need our heat?
We're going to need every bit of it. Yes, during the last little ice age, this comes from H.H. Lamb, who was probably one of the world's greatest climatologists, but he studied the little ice age, and he said that in the 1600s, during that period, that in the little ice age, they know it was a little ice age because farmers were petitioning their local governments for lower taxes because their fields were covered with ice. But what happened in the United Kingdom is that the rainy season lasted for 5 weeks longer than normal. It meant that the farmers weren't able to plant their fields. Literally millions of people died of starvation. I think that the global cooling is so much worse than any idea of global warming.
Yeah, a couple of things with that, Kim. I had the privilege of visiting with Hubert Lamb at East Anglia on a few occasions while I was doing my doctoral thesis. And Bob's right. He's the father of historical climate. Reed Bryson, of course, in the U.S. also I want to give kudos to. But just to emphasize Bob's point, you don't understand history if you don't understand climate change. I mean, you don't understand the fur trade and the demand for furs unless you understand how cold it was. For example, in 1683, there were 3 feet of ice on the Thames River in London, England. And as we're heading now, with the decreasing sunspot activity, that's entirely within the realm. But there's a couple of other points I want to make. One is we talked about environmentalism, and one of the attacks that is made against those of us that dare to raise questions is, we're not environmentalists, we don't care. Environmentalism was in a new paradigm absolutely essential. We needed to start living within the confines of our Earth and being aware of our environment and so on. But a small group took the high ground. They get up there saying, we're the only ones that care about the environment. We all care about the environment. How dare these people steal that moral high ground and then preach to us about how we should live and what we should do? And of course, they're partly doing it because it's the new religion. So that idea is infuriating. But another point, probably the most hostile reaction I've got, and I've got death threats included in that, was to an article I wrote saying, what's wrong with global warming? As Bob is implying, I mean, for flora and fauna and the human condition, the Earth and people are much better off with a warmer world. And yet all we hear is the negative impacts of warming. I mean, Britain going on about, there's going to be more deaths due to the warming. Well, far more people die every winter in Britain from the cold than from the heat. And yet that's never mentioned. And so it's such a biased presentation of the whole thing, and again, this marginalizing of people. And of course, the real problem is that the politicians are leading us to prepare for warming, and it's cooling. And from an agricultural point of view, it may be that the only hope we've got is genetic modification to produce the plants that will allow us to adapt quickly.
I hope that not ends up being what's needed, is to have to genetically modify food. That's a whole other show, and hopefully.
Well, of course it is, but
I hope we don't have to.
If you take the wrong action, you paint yourself into a corner.
Sure. Definitely.
I believe that we'll look back on the decades of the late 20th century and the early part of this decade here as the modern climate optimum. Shake our head how we didn't know how good we had it. That NASA's been able to see from satellite an increase in crop greening or crop yields by a factor of 3 in the past 50 years, with 10% more land that's arable because of slight warming, more rainfall, as Bob has said, and increased CO2. And plants love CO2. In greenhouses, they pump in CO2 at 3 times the ambient or outside level to get the plants to grow more vigorously. That when they put them out in display, they don't look as good after a few days, and part of that is because they're starving from CO2. Part of that is, of course, the sunshine, extreme temperatures and changes in humidity. But plants benefit from CO2, and we forget that. CO2 is a benefit more than it is a problem, and we need to recognize that.
Joe, can I add to that? And
Sure.
They've tried to label CO2 as a pollutant. And, of course, that's also tied in with the confusion between carbon and CO2. As we've already talked about, CO2 is essential to plant life. Recently, the EPA listed it as CO2 as a toxic substance, or said they were planning to. And, of course, under American law, you have a chance to write and argue against that proposal. I don't think it is falling on deaf ears. But one of the things that I proposed was that we get power of attorney for the plants, so that if they want to reduce CO2 in the atmosphere, we should vote on behalf of the plants. And as Joe is indicating, at 385 parts per million, which is the current level, the plants are essentially malnourished. Sherwood Idso, who has also been fighting this battle for a very long time, and I've known Sherwood for 30 years, and his son Craig, they've done research showing how much better plants grow at up to 1,000 to 1,200 parts per million. In other words, as Joe said, 3 to 4 times. Commercial greenhouses, as Joe implied, are doing that. And one of the things is when you look back at the geologic record, you see that at 385 parts per million, contrary to what Gore is saying, that is the lowest readings in 600 million years.
Wow.
Look at the last... Right, and if you look at the last 300 million years, the average is 1,000 to 1,200 parts per million. And what it appears to indicate is that the plants, which mostly evolved during that period of time, that is the level that they prefer. And that's what's showing up with the commercial use of the CO2 and in the work by Sherwood Idso and so on. And by the way, if the level goes down, then 250 parts per million, the plants start to die. And of course, you start reducing the amount of oxygen in the atmosphere. And without that oxygen, there's no life on Earth. And I sometimes wonder if that isn't the ultimate goal of some of the extreme environmentalists, that if we could just get rid of the people on the planet, it would be a great place to live.
Let me ask either Joe or
Is this Bob? Is this Bob from IceAgeNow.com speaking? Okay, great.
Bob. I have a question, Joe or Tim. But Joe, you said that they pump the CO2 into the greenhouses, and I wonder, do people still work in those greenhouses, and are they surviving that 1,000 parts per million very well?
Very well. And as Tim has mentioned, the work of Craig Idso has shown that with a tripling of the CO2, one experiment in South America, they got 40% increase in biomass for their sugarcane in a field with 3 times the CO2. Now, in submarines where the air is trapped, CO2 levels reach 6,000 parts per million. It is still not harmful at that or toxic at that level. In most auditoriums where people listen to lectures about global warming and how bad CO2 is, it's not uncommon to have CO2 levels increase to 3 times the level of the air outside. So
I would just support that, Joe. And in fact, in mines, the level that's considered the point at which you shouldn't stay longer than 15 minutes is 5,000 parts per million. So we've got that in the health and safety standards. But as you said, you can get a small auditorium and you can actually have levels of 10, 12,000 and really no effect on people. Now, if you stayed there for a long time, you get drowsiness and so on. But to suggest that anything above 385 is harmful to anything or anybody is simply absolute scientific rubbish. But of course, that's what they want to promote.
Okay, we've gone through just about every element, almost every element that's part of the wheel of this subject, meaning climate and weather. My question now is, what's next if, in fact, Bob Felix is correct and a little ice age is on the way? Well, first of all, I want to say something. I would bet 99.9% of all people cannot fathom a swift weather change like that, A. B, will not consider it because it's not part of our paradigm for living on the earth. When I did that show with Carol Rosin a few years ago, we talked about how the earth is in space. And because the earth is in space, and we're so based here and focused here, most of us don't have an awareness that we're living in outer space on Earth. And that context keeps us from understanding that we're part of a bigger picture, a bigger phenomenon, a cosmic phenomenon, just being alive. And so I don't see that most people, even if you get a percentage of the population to think about and consider that what we're being told is erroneous science that is being skewed, I'm not sure that people are willing to consider that we may encounter and be alive for an ice age that's coming. Because when you even think about it, it brings about an ancient feeling, an ancient reference that ice ages happened to people in the past, not to us, not with modern technology. There's a whole psyche to thinking about this. It's part of what was. It's not part of the modern Earth that's all technology based, that's into nanotechnology, that can do wars in space, that things can happen very quickly, They have Ray Kurzweil talking about the singularity is here and the singularity has arrived and everything's coming into an exponential speed. So I think with the focus being on the internet and the focus on a digital economy, even though the original economy is imploding and the banking system is imploding. I did a show on that with Ellen Brown a few weeks ago. The fact is that most humans, they can comprehend hurricanes, they can comprehend floods, they can comprehend bad weather, they can comprehend some parts of extreme weather. But when you talk about the whole gestalt of weather and climate and the possibility that changes are coming that we do not and cannot control, that are more powerful than what woman can do anything about, a lot of people will feel hopeless and will feel afraid because it will change the face of how to prepare. The preparations for an erroneous global warming construct are different than the preparations for a pending ice age. Totally.
Absolutely.
Including where you're going to buy property, where you're going to set up shop for the next 10, 20 years. Am I correct, Bob Felix? Tell me.
Absolutely. First I'd like to say the IPCC, I think those initials stand for irresponsible political climate cover-up. With that said, yes, we're being prepared for global warming. I think if people knew the truth, you asked what could happen in the future, I think if we knew the truth, that we could handle this. I mean, if you put me on a plane to Alaska and you tell me in advance that I'm going to Alaska, I'll figure out what to do. And people will figure out what to do. But if you put me on a plane, tell me I'm going to Miami, and I prepare for Miami, and then you dump me off in Alaska, I'm in a heap of trouble. And I think that's what's happening right now. We're being told it's global warming, we're being told we're going to Miami, and we're headed in the opposite direction. So tell us the truth, and people will figure out what what to do.
I think that people will figure out what to do, but I think they're going to need whole systems guidance on how to even begin formulating the right questions. For example, if you want to talk about insulation for your home or for a property, and you're not thinking of geomagnetic storms, or you're not thinking of tremendous amounts of ice coming, you're preparing totally for the wrong thing. And no matter how much you green your environment, quote, end quote, no matter how much you do organic and you make your materials from everything natural, it won't work to support wrong assumptions.
I keep hearing this talk about the rising sea levels, and I see it going in the other direction. During the last ice age, sea levels were 370 feet lower than they are right now. That's where all the moisture came from to build up those ice sheets 2 miles thick, covering Canada, covering parts of the United States. But one thing I'd like to leave with people, too, is that just because we're in an ice age doesn't mean it's going to be that much colder.
See, that's what we don't understand.
No, people don't understand that. During the last ice age, Seattle was covered with 4,000 feet of ice, 4/5 of a mile straight up. But the ice only extended as far south as Olympia. 150 miles south of Olympia, it was only about 7 degrees colder than it is right now. The ice then, and I do have a map of this on iceagenow.com, but the ice then moved north so that Coeur d'Alene, Idaho was not covered with ice. Then the ice essentially followed the Missouri River. So on the north side of the Missouri River, there was a cliff of ice 15 stories high. But on the south side of the Missouri River, people could have survived. In my past, I've lived in Juneau, Alaska, just a quarter mile in front of the Mendenhall Glacier. No problem. We can live in conjunction with that, but we would have to change our planting habits. There would have to be lots more farms developed further south.
Would planting need to happen through things like hydroponic?
I would think that would be good. I think greenhouses will be like gold. And the climate changes at that point, like in the American Southwest during an ice age. At least during the previous ice age, it was a lot wetter, so things would have grown better. So there's a lot of things that we could be looking at and preparing for.
What do you think is going to happen with Canada, Bob?
Well, can I answer that as a Canadian?
Sure.
You Americans better stand by for 38 million Canadians moving south. That's the threat, and we'll bring our healthcare system with us too. So watch out. But I think that there's an important point to make here, a couple of important points. One is, you mentioned the term extreme weather. It's not extreme weather. Hurricanes are normal weather.
Okay.
It's just that they are problematic for humans, or if your house is in the way. And so you watch it on CNN now. They have severe weather.
I think that's just for
normal weather.
Yeah.
So that's the first thing. The second thing is all of the focus, and I agree, it's fine. I agree with what Bob is doing. The focus is on temperature, but we've also hinted, and I talked about it with snow on glaciers. What's the precipitation going to do? They're telling us, there's going to be more droughts. Well, that's counterintuitive, because if it warms up, there's more water vapor in the atmosphere and the potential for more rain, not less. But they know that droughts, and I taught a water resources class because I realized from studying climate that drought is the single biggest impact on flora and fauna and the human condition. And so what's the precipitation going to do? That will have as big an impact as the temperature change. And of course, as Bob is saying, that you simply, areas that currently can't produce will in fact be able to produce foodstuffs and those kinds of adjustments. Now, how that will be affected by boundaries and nation states and so on is another matter. But I think that there's a couple of important things here. One is, of course, the immediate consequence of the policies that are coming out of the carbon being the problem, or CO2 being the problem, and how that's going to destroy Western economies particularly. Clearly, China's not going to go along with it, and neither is India. And India have trumped the environmentalists by saying, look, we've got people starving to death. We want to get our priorities straight here. And so you'll see a huge change in the
the balance of power within the world. That's the first thing in a short basis. But I think in a longer term, as it cools down, the food production becomes a big problem. And as Bob talked about with that little ice age in Britain and Europe, I mean, the harvest failures and the difficulties that it created, and of course so much of the migration of the Caucasian people, the Europeans, to North America came about because of those severe conditions in Europe at that time. It wasn't just the political. The political unrest was due to food supply problems, but the response was the migration, and so I think we're likely to see a lot of those things. But we've got such a rigid system in place that whether we can accommodate them is another question.
You talked about the mass migration. There's a cycle. I've been talking about the big cycle of ice ages, but there's a smaller cycle of little ice ages, which essentially correlate with the sunspot cycle. A little ice age approximately every 360 years. The collapse of civilizations matched the little ice age cycle. The Sumerian civilization collapsed in sync with the little ice age cycle. The Roman civilization collapsed in sync with that cycle. The Greek civilization collapsed in sync with that cycle. Genghis Khan swept out of the north in sync with that little cycle, that little ice age cycle. And I fear that we're going to be seeing the collapse of modern day civilizations in sync with that same cycle.
I would point out that we had a mini migration in the 1960s and 70s when we had some very cold weather and cold winters to the southern part of the United States. The population of places in Georgia and Florida increased rapidly at the expense of northern states. And the public is prepared for global warming, as you said, and they're being told that they have to watch out for more heat waves. The heat waves are increasing. And the actual fact is if you look at the data, we've had less heat records in this decade, the 2000s, and it's coming close to ending, than any decade since the 1800s. It isn't there. When I talk about, I gave a talk yesterday to a large group of people, and I talked about the cycles like Bob talked about, the longer range, and also there's a 60-year cycle. It's very evident that ties to the sun and cycles in the ocean. And I talk about volcanism to the public. But I always get questions afterwards. They'll come back and say, but Joe, what about the Arctic? What about the polar bear? Those images in the Inconvenient Truth they saw. The images in the movie and in Inconvenient Truth were very powerful of the polar bear and the Arctic ice. But you can explain that away, as I discussed, from the old warm ocean cycles and the intrusion of warm water into the Arctic. And perhaps with Gackle Ridge volcanism underneath the Arctic, they discovered a large volcano took place in 1999 that may have contributed to the decline of the ice in the last decade. And the Kilimanjaro they ask about. They say, well, you talk about glaciers increasing. What about Kilimanjaro? I see pictures that it is decreasing. But as Tim pointed out, it's not just temperature that determines whether a glacier will advance or decline. The temperatures at Kilimanjaro for the last 25 years have been declining, but the ice has been decreasing because there's been a significant amount of deforestation in Central Africa near Kilimanjaro. With less trees, there's less moisture, less thunderstorms. Those thunderstorms are what deliver the snow to the higher elevation that build a glacier, and so it's been retreating from lack of precipitation, not because of any warming. And when you explain those things away, it helps the public then to perhaps accept your position on
just one. Yeah. Joe, one thing to add to the Kilimanjaro thing, with the deforestation and increase of agriculture, of course, more dust in the atmosphere, and the dust falls on the snow, darkens it, and, of course, makes it melt more quickly because of the change of the albedo, more sunlight affecting it. So that's another small factor with Kilimanjaro as well.
And Joe, I'd like to come in there, too, because you mentioned the Gackle Ridge in the Arctic Ocean. And I don't think people realize that there are underwater volcanoes in the Arctic Ocean. That's what I think is heating the ocean. The Max Planck Institute sent submersibles down into the Arctic Ocean to look at the Gackle Ridge. Now, the Gackle Ridge is 1,100 miles long. It's a chain of underwater mountains, underwater volcanoes, bigger than the Alps. And they were wondering if that was active. Well, they discovered that the Gackel Ridge is so active that they had to be careful that the heat didn't melt the cables on their submersibles. So that is what I think is heating the Arctic Ocean. I don't know how some farmer in Nebraska driving his tractor in a cornfield is going to be heating the below water temperatures in the Arctic Ocean. It's got to be coming locally.
And the same thing is happening in the Antarctic, near the Antarctic Peninsula. It is a volcanic region with volcanoes on the peninsula, above the ground, above the ice, but also underneath. And they are active underneath, and they are maybe doing the same thing, warming the water from beneath and melting the ice from beneath and causing some decay of the ice in the western part of Antarctica.
We had This is Bob again. We had mentioned about the food production, and that's one of the things I say, not by fire but by ice. I fear that we will be fighting in the streets for food long before we're covered by ice. So I would certainly recommend that people would at least have a food supply on hand.
I wouldn't disagree with that, Bob, and Chris. One could argue that's one of the reasons that the Mormons require you have a 1 year food supply in your house. But when you look at, I've worked with Chinese climatologists and with Russian, Borisenkov in particular, and they have very, very long records of both crop conditions and production and the weather. And not because they cared about the weather and how it affected, but because they knew if there was crop failure, then there was going to be social unrest, and they wanted to get the troops in place to stop the unrest. Most revolutions, the French Revolution, for example, there's always been the animosity between the aristocracy and the peasants. But what triggered it was the harvest failures, which, by the way, Benjamin Franklin predicted because of the volcanic eruptions in Iceland and peasants spending 1 year, the first year, about 55% of their total income just on bread, and then in the second year, 82% of their total income just on bread, and the third year, of course, they stormed the Bastille. And so when you look at history, it is the failure of the food supply that causes people to rise up, because mostly people will tolerate incredibly bad government, as we prove every year, but when it comes down to food, then it becomes a very, very critical issue, and I think that your point on that is well taken.
And it's aggravated by the fact that if energy prices go up, then people at the lower income have to decide between heating and eating, and that's already taking place in parts of Europe and in England when they had an extremely cold winter. There were stories of women, retirement, widows, living in their little apartments with the thermostat set at 50 degrees with their coat on during the day, and the cold went on for over a week, and they had to, even with that lowered thermostat, they had very little money and had to ration their food. And there were stories of people actually starving because they couldn't afford to buy food in Michigan last winter.
I think one of the things that people forget is that before the Industrial Revolution, there was an agricultural revolution. And one of the great achievements of the U.S., besides the concept of democracy and free speech and so on, is the fact that the U.S. has reached the point where 2% of the population producing enough food for the other 98% with food left over to export. And so what we forget, and the economists forget, is that the basis of all civilization is surplus food. Surplus food is surplus time, and then you can create and do all the other things you want to do. So if we see that food supply diminish, then it as Joe is implying and Bob is implying, it eats into your time and takes away. And that's one of the concerns I have too, is because if we push the energy prices up for completely unnecessarily because of the supposed CO2 problem, and the potential within the society to come up with the solutions, to have the free time and have the people working on these issues is also diminished.
I think we're at a time where things are already happening, and I think that everything is already on its way. The question is not how many people can you get the message to, but how many people that you get the message to or make the message and the information and the science and the history available to them are going to be receptive to rethinking this subject, because it really has to do with getting into a totally different mindset and not thinking of ice ages or weather as something local, but something from outer space and something from volcanism and something that has to do with different elements that are all connected and related, but it's ancient. This is an ancient phenomenon that is reoccurring and reemerging as it always has been, and it's natural. And so for the people who are advocates, let's say this, for those who are formal advocates and it's been their mission to help the earth and to create organic products and to save trees and save the environment, etc., all power to them. But at the same time, there needs to be an expansion of what that means with different scientific grounding that's verifiable, and putting all the puzzle pieces together to say they're not wrong and we're not wrong for being, let's say, an environmental passionate advocate, right? Not that others aren't, but people who are in that category perceive themselves as being the ones, right, who are. But now, how do they take that passion and that connectedness and that concern and open their field of receptivity to allow in a more complete composite of input, more substantive whole systems input that has no political agenda except to help prepare people for the coming time? And yeah, that's the task, I think.
Yeah, Kim, can I just a quick comment about that, because I've been involved in this for almost 40 years now, and so on. The most common comment I get after a presentation, well, there's two. One is I had my suspicions, but I didn't know enough to know. That applies to most of the public. Michael Crichton, who, by the way, shared a room at Harvard with Richard Lindzen, which is where he got all the science for his book, State of Fear. But the state of fear it has been exploited. The Chicken Little, the sky is falling, and so on. And the other thing that's been exploited, and that's what we're talking about here, is the people's lack of understanding and knowledge. Only 20% of the population are comfortable with science. You can see this in it. I used to laugh at the students about it. I said 80% of you will avoid lab courses like the plague. 20% of you are comfortable in lab courses. And where we see that in the society is I have yet to meet a journalist who knows anything about science, let alone climate science. And of course, that means that they don't understand when you tell them. And if they're looking at the science, is looking for sensationalism. And then, of course, what's fed to them at, oh, the world's going to fry and it's the end of the world and all of this stuff, that sells. Now, on the other side, so what I'm saying is then the public generally are receptive. The public are generally healthily skeptical about things. They've heard all the doomsayers before, but they just simply are still afraid, and the politicians are afraid to speak out, because the politicians will say to me, yeah, well, we agree, we know, but it's political suicide right now to suggest that we might even, not care about the environment in any, even a little bit. So we've got that going on.
Politicians have defined the navigational structure of the conversation so that if you navigate certain terrain to verify evidence for something, you're in a political minefield. Yep. And so it's that the construction, the architecture of the focus is already set, and the dialogue is set, and the energetic minefields in the public ethos, the psychological, sociological, emotional ethos is already prepared. And the collective concern fit perfectly into this story that we've been fed, and which I bought. I bought that story. It fit a lot of things that made sense to me, and I had zero scientific understanding. I mean, if it weren't for Robert Felix's books, Magnetic Reversals and Evolutionary Leaps, and Not by Fire, but by Ice, and going to IceAgeNow.com to even get a handle on some of it, even getting a handle on some of the truths that are verifiable, pattern, that this is a cycle, that cycles correlate to changes in the sun, changes in the magnetic field, field, that it has to do with extinctions. Even just this little but big part is a revelation for somebody who knows nothing, who bought the story. Yet, I'm a committed individual. I've been on a mission for 25 years. I've covered subjects with its rainmaking time. I mean, I interviewed Muhammad Yunus of the Grameen Bank before he got the Nobel Prize. America wasn't interested in him. I went all over to satellite networks, to radio and television networks with a 1-hour blockbuster interview with him. Nobody cared, not public broadcasting nor private broadcasting. XM was interested in $500 million going to Howard Stern. Their pipelines were booked. It's like this type of content, which is about true discovery, has to be provisioned for with regard to doing programming. The reality is that this is the story that's selling. I bought it, and millions of other people are buying into it. So I'm delighted that you've all taken your time today on a Sunday when you could have been with your families right now doing many other things and working with me to try to get the public on board with the most important ways that they need to be thinking about this. And the reality is that nobody can afford to be wrong. Nobody can afford to be wrong on this. And I know that Europe can't afford to be wrong, because the first places that are going to go could potentially go into an ice age is Europe. I wouldn't believe anybody if they told me the Queen of England and the monarchy doesn't have grave concerns. I would bet anybody that the people who are watching what's going on with weather know exactly what's going on with the weather. The real people watching the weather put a doomsday seed vault, was it in Antarctica or the North Pole, with 20,000 seeds there. I mean, what's going on? Something's being prepared for. Somebody knows something that's going on, and it's not just ideology or conjecture. Something's shifting. Concurrently, with real knowledge of what's going on, which you've all been sharing, there is a running to seize control over the new industrial complex that its basis is on this carbon trade and tax and footprint. An entire industrial international complex is on the way. And what's happening is that once you buy the seed is off, and then you're running off with the tree of new fortune that are to be made in this new industrial complex. Even a portion of what you're all saying is true. This is sacrilegious to humanity, to all plant life, to animals, to this planet, and to civilization in general. And so I'm stupefied. And I would like this to get to as many people as possible. I'd like to invite you to please put links to this when it's up on the site. It's rainmaking time. I'd like to invite you back with some other people on the show, astrophysicists, possibly to do a TV piece of this. But I think that as a basic grounding, you have covered it today. You have more than covered it today. Again, if only 20% of what you're saying is true, we're in trouble. And so on behalf of people all over the world, this generation and future generations, I want to invite you all back to its rainmaking time and to please link this to your sites. Let as many people know about this as possible. And I really thank you for coming here today. We're not done. We started the conversation, and I'm very honored that you've been here. Thank you so much. Thank you, Robert Felix, author of Magnetic Reversals and Evolutionary Leaps, Not by Fire, but by Ice. Joe D'Aleo, the founder of icecaps.us, and Dr. Tim Ball, a climatologist, a wonderful climatologist in Canada. I thank you from its rainmaking time. God bless you.